everyone, welcome to Techsync. Let's get started with Arduino. In this session, we are going to cover different topics like what is Arduino, why Arduino is important, why are you here, why are you learning this, basic things about Arduino, different Arduino boards, the components used in Arduino. I think you people can see this board here and there are many things in this board. And finally, how and where to do this programming. There are a lot of queries related to this. Related to cost and all, money, where to buy, what are all things. So we will explore all these in the session here. So let's get started. Before starting, make sure that you have a pen and paper in your hand, put your phones on focus mode, and let's get started. Ready? So the first question is, what is Arduino? So I think you people can see the board here. Many people have the myth that Arduino is the board itself, but it is not. So Arduino is an open source hardware and software company. It manufactures single board microcontrollers and microcontroller kits. Arduino board designs use variety of microprocessors and microcontrollers. This board contains sets of digital and analog input-output pins interfaced to various expansion boards or breadboards and other circuits. It is programmed using C and C++ programming languages. Okay, now here comes the most important question. Why Arduino? Why is it important? The simple answer is, if you want to learn robotics, you should definitely start with Arduino. Robotics is a high-paying career. Robotics industry is expected to grow significantly over the coming years. It is an excellent area to study because it combines mechanical, electronic, and computer engineering. It is a highly demanding field of engineering and it is rewarding as well in terms of job prospects. Most of the jobs gonna be replaced by robots, like in industries, cooking, service sector, and entertainment, music, health, and almost every area. So, for those people who have passion in robotics, and if you don't know where to start, then this is the right place. So there are actually 3 steps to master robotics. The first, learn C program. Second, learn Arduino. That is why you people are here. And the third, get started with robotics. That's all. And talking more about Arduino, it is a simple, accessible user experience. Thousands of different projects and applications are available here. It is easy to use for beginners, yet flexible enough for advanced users. It runs on Windows, Mac, and Linux. Okay? Now, here are the basics. The goal of Arduino is to create an accessible way for software developers to enter the world of microprogramming. Arduino is a microcontroller interface built around an 8 Mega processor, coupled with an integrated development environment for creating logic on chip. Arduino has 3 main parts: structures, values, and functions. This values means variables and constants. And if you're wondering what is this integrated development environment, as we know, unlike humans, we are dealing with machines or computers. So we need a medium to communicate. We need to communicate with them in a specific language. That is why we are using C and C++. These are the programming languages, the languages that computer understands. And we need a medium, we need a place where we could talk to computer, right? So that environment, that place where we could communicate is the integrated development environment. That is what we call this IDE. So now we're going to discuss about different Arduino boards. There are many boards: Arduino Uno, R3, Nano, Micro, Due, Lillypad Arduino board, Arduino BT or Arduino Bluetooth Arduino Dismelia, Red Arduino board, Arduino Mega R3 board, Leonardo board, Arduino Robot, Arduino Explorer, Arduino Pro Micro, Arduino Ethernet, Arduino Zero, fastest Arduino board. There are many. Okay, but we gonna mainly focus on Arduino Uno R3 because this is the easiest board and this is the best board to begin for you people. So we're gonna learn this Arduino Uno R3 board in detail, but we're gonna cover all these boards. We're gonna learn about all these boards because for a general idea about all these Arduino boards, we will discuss all this here. So first, Arduino Uno R3. Let's see what it is. So this is Arduino Uno R3. Arduino Uno R3 is a huge option for your initial Arduino. This board depends on an 8 Mega 328P based microcontroller. As compared with other types of Arduino boards, it is very simple to use, like Arduino Mega type board. It consists of 14 digital I/O pins, input-output pins. That is here. I think you can say this digital PWM written in it, and you can see this numbers from 0 to 13. So 14 in total, and you can see some tilt or curly arrow between some numericals like 11, 10, 9, 6, 5, 3 and all. And this is called tilt. And what does this mean is that it supports PWM or pulse width modulation outputs. and 6 analog pins that is somewhere here that starts from A0 to A5. So total 6. And a reset button. There are actually two, one here and one here. No worries, we will discuss all this in the component session. So I'm giving a general idea now. A power jack, a USB connection. This is the USB connection. This is the part where we're gonna connect it with the computer. Okay. And an in-circuit serial programming header, IC, SP, etc. It includes everything required to hold up the microcontroller. Simply attach it to a PC with the help of a USB cable. Give the supply to get started with an AC to DC adapter or battery. This is the power port. Okay. Or we call this the power jack. And this Arduino Uno is the most frequently used board, and it is the standard form apart from all existing Arduino board. This board is very useful for beginners. Okay. Now Arduino Nano. It is a small board based on the microcontrollers like Mega 328P, otherwise Mega 628. But the connection of this board is same as the Arduino Uno board. Like most of the things, this kind of Arduino board is very small in size, sustainable, flexible and reliable. Okay. Now Arduino Micro. Here it has 20 sets of pins. The USB connection is inbuilt, and it is the shrunk version of Leonardo board. Okay. Now Arduino Due. This Arduino board depends on the ARM Cortex M3, and it is the first Arduino microcontroller board. Okay, this board works with 3.3 volt, where the highest voltage that the pins of input or output can stand is 3.3 volt, because providing a high voltage to any input output pin can lead to damage the board. This board is simply connected to a computer through a small USB cable, otherwise it can be powered through an AC to DC adapter. This Arduino Due board is suitable with all shells of Arduino at 3.3 volt. Now Lillypad Arduino board. This is a wearable e-textile technology, where these are even washable, design with huge connecting pads and smooth pack. Arduino Bluetooth, or what we call as Arduino BT. The programming of this BT controller can be done with Bluetooth like a wireless connection, and it depends on the microcontroller at Mega 168. Now Arduino Dismelia. It is the latest version and it is Italian, and it depends on at Mega 168. Okay. This is the Redboard Arduino board. It is programmed using mini USB cable using Arduino IDE, and it is simple to utilize. This is Arduino Mega R3 board. Similar to Uno's big brother, it is helpful in designing projects that need a bunch of digital input pins or output pins, like lots of buttons. Okay. Now here comes the Leonardo board, Arduino Leonardo board. It is the first development board of Arduino that uses one microcontroller along with USB. It is simple and cheap. Now Arduino Robot. This is the first Arduino over wheels. It has two processors on each of its boards, motor and control board. It depends on Mega 32U4, programming same as the Arduino Leonardo board. Now here comes Arduino Explorer. It looks like a video game controller. As compared with all other boards, Explorer is totally different because inputs and outputs are connected to the board already. It includes its own library, so data from sensors and actuators are very easy to read and write. Here comes Arduino Pro micro board. It is same as the Arduino mini board apart from the Mega 32U4 microcontroller. This Pro micro board includes digital I/O pins 12, pulse width modulation pins 5, serial connections, TXRX and 10-bit ADC. Now Arduino Ethernet. Arduino Ethernet board depends on the microcontroller like Mega 328. This kind of microcontroller includes analog pins, digital I/O pins 14, reset button, and RJ45 connection, crystal oscillator, a power jack, IC, SP header, etc. The connection of Arduino board can be done through Ethernet shield to the internet. Then Arduino Zero. It is powerful as well as simple. 32-bit board, best for innovative projects like wearable technology, smart IoT devices, crazy robotics, high-tech automation, power-driven through SADM21 microcontroller based on ADML. The main feature is the embedded debugger that provides complete debug without using extra hardware. Okay, now here comes the fastest Arduino board. This kind of fastest board has Cortex M7 with a 400 MHz microcontroller. Learn about the components of Arduino. This is the Arduino Uno R3 board. This is a reset switch. You can also see one more written reset here. This is a USB connector where you can connect this with the computer. And this is a USB interface chip. It's a crystal oscillator. It's the voltage regulator which is between this USB connector and power port. And here are the digital pins. Here are the TXRX LEDs, and you can see one on LED here. There's another LED which is directly connected with this 13th pin. Here's the Mega R3 microcontroller. Here are 6 analog pins. And here is the 3.3 volt output, 5 volt output. You can provide grounding here, here, and here. Actually, GND is written here. And this is the V input. There are so many things. We could learn all this one by one in this session. And this is the more detailed version of Arduino Uno board. First, USB connector. This is the USB connector. As we told earlier, we are connecting this to the computer. This is a printed USB port used to load a program from the Arduino IDE onto the Arduino board. The board can also be powered through this port. Okay. Now here comes the power port. This is the power port. Actually, we call this as the power jack and this as the 2.1 mm center positive plug. The Arduino board can be powered through an AC to DC adapter or a battery. The power source can be connected by plugging a 2.1 mm center positive plug into the power jack of the board. The Arduino Uno board operates at voltage of 5 volts, but it can stand a maximum of 20 volts. If the board is supplied with a higher voltage, there is a voltage regulator. It sits between the power port and USB connector that protects the board from burning out. It's somewhere here between this USB connector and power jack. Now microcontroller. This is the microcontroller. This is the Mega 328P microcontroller. It is the most prominent black rectangular shape with 28 pins. Think of it as the brains of your Arduino. The microcontroller used on the Uno board is Mega 328P by Atmel. Actually, Atmel is a major microcontroller manufacturer. Mega 328P has the following components in it. First is the flash memory of 32 KB. The program loaded from Arduino IDE is stored here. RAM of 2 KB. This is the runtime memory. And then the CPU, it controls everything that goes on within the device. It fetches the program instructions from flash memory and runs them with the help of RAM. Then electrically erasable programmable read-only memory, or the EEPROM, of 1 KB. This is a type of non-volatile memory and it keeps the data even after the device restart and reset. The Mega 328P is a pre-program with bootloader. This allows you to directly upload a new Arduino program into the device without using any external hardware programmer, making the Arduino Uno board easy to use. Now here comes the analog input pins. You know why these analog pins are used? In the case of digital pins, it consists of fixed values like 1, 2, 3, 4, 5, like that. But in the case of temperatures, if you are using temperature sensors, we will have between values. Like, this is just an example, 37.5, 38.6. If we have these kind of values, we need something to convert it into digital pins, right? So that is why we are using these digital inputs. It ranges from A0, there are 6 digital input pins, that is A0, A1, A2, A3, A4, A5, etc. So the Arduino board has 6 analog input pins labeled analog A0 to 5. These pins can read the signal from an analog sensor like temperature sensor and convert it into digital value so that the system understands. These pins just measure voltage and not the current because they have very high internal resistance. Hence, only a small amount of current flows through these pins. Although these pins are labeled analog and are analog input by default, these pins can also be used for digital input or output. Okay. Now here comes the digital pins. As you can see, 14 digital pins here starting from 0 to 13. You can find these pins labeled digital 0 to 13. These pins can be used as either input or output pins. When used as output, these pins act as a power supply source for the components connected to them. When used as input pins, they read the signals from the component connected to them. When digital pins are used as output pins, they supply 40 milliamperes of current as 5 volts, which is more than enough to light an LED. Some of the digital pins are labeled with tilt symbol. I already mentioned this symbol, this curly arrow before this 11, 10, 9, 6, 5, 3 and all. What does this represent is the symbol next to the pin numbers 3, 5, 6, 9, 10, 11. These pins act as normal digital pins but can also be used for pulse width modulation PWM that stimulates analog output like fading and LED in and out. Now this is the reset switch. I'm already mentioned there is one more here. Actually, what is the function of this reset switch is that if you don't want to repeat a program and if you want to test the program if it is doing properly, then use this. When the switch is clicked, it sends a logical pulse to the reset pin of microcontroller and now runs the program again from the start. This can be very useful if your code doesn't repeat but want to test it multiple times. Okay. Now here comes the crystal oscillator. This is the crystal oscillator, the quartz crystal oscillator, which takes 16 million times a second. On each tick, the microcontroller performs one operation. For example, addition, subtraction, etc. We already mentioned this earlier. Here comes the TXRX LEDs. Actually, this TX stands for transmit and this RX stands for receiving. TX stands for transmit and RX for receive. These are indicator LEDs which blink whenever the Uno board is transmitting or receiving data. Now that you have explored the Uno board, you have started your journey toward building your first IoT prototype. In the next article, we will discuss the Arduino programming and do a few experiments with Arduino and LEDs. So finally, we are going with how we are going to program this, where the possibility, availability, cost and all, and how to do programming and Arduino. So there are two possibilities. First, you can buy an Arduino board, but it requires money. So first option we can discuss, buy an Arduino board, use Arduino Uno on Arduino Web IDE, use Arduino Uno on Arduino Desktop. On the Arduino Desktop IDE, install the board drivers, open your first sketch, select your board type and port. Then upload program and call, then initiate. That's all. But in this session, we are not getting much into it because we are now going to do it for free. Let's do it free of cost. Actually, we have something called Tinkercad. It is free, easy to use web app that equips the next generation designers and engineers with foundational skills for innovation. So let's do some programming. For doing programming in Arduino, we want Tinkercad. Actually, I already have account in Tinkercad. Otherwise, you can just search for Tinkercad and you have to sign in. But I already have one account, so I'm just logging in. So what we're going to do is we are going to deal with circuits. We will click the circuit and then create new circuit. Okay. So what we will do is we just check for an Arduino board. You can see all this board here, NeoPixel Jewel. These are the breadboard, and here comes the microcontrollers. This is our Uno R3 board. Wow, I love this board. Then we need to light one LED. For that we need one resistor, and we can choose one LED. Actually, we can change this color and all, maybe green, but I like this red color. I'm going with it. Okay, this resistor. $128, and this is the anode and this is the cathode, and you can see grounding here. Actually, what we're going to do is we want to light this LED. This 13th pin is directly connected to this LED. We're going to connect this cathode to ground. Okay. Now what we want to do is we have to program. For this we are taking text. Are you sure you want to close the blocks editor? You should select continue because we want to. So this is the void setup. Here you can give only one instruction, and here we can do many. This is the pin mode. This is how we do the programming. It should be like this itself, like PIN in small letters and this M capitalized and all other small. And you should end this with a semicolon. otherwise this computer can't understand. And since we are giving this output to 13th LED, we are going to replace this with 13. And this is the void loop. Here it is the digital right LED bulletin. So we want to blink this. So blink this LED which is connected to 13th pin. So we're going to replace it with 13. And here the delay given is 1000 millisecond. Actually 1000 millisecond is actually 1 second. Maybe we could change that number also. We could change this to maybe 900. And we have to blink this. So we have to provide this low digital right LED bulletin. It's also 13. So we can change this delay time also with 100 maybe, and wait for 1000 milliseconds. Just try stimulating that. I hope you can see this LED blinking here. Stop stimulation. Actually, I want to blink it in a different way. Maybe this 1000. And this also 1000. So blinking will be more beautiful. This is another way of blinking this LED. And actually see this, here is the switch on, not switch, the LED on. And this is directly connected to 13. So this LED is also blinking according to the LED connected here. And if we have done any mistake, it won't operate. Let's see. Look at this. Some error is shown. Sorry, it seems like your code has some error in function void loop. Yes, we didn't put the semicolon. So that's the error. So it is mentioning here. So we will correct this. Now let's start stimulation once again. And now no error. So now it's properly blinking. And actually we can try different patterns here. Maybe this, we can stop stimulation and continue editing. So the delay is reduced to 100. See how it's, now the delay is reduced. Maybe we could change this to 750. See how this lights. So I think you can try different patterns here. It's all about understanding, not about too much explaining or just by hearting. It's all about understanding this. For learning programming, what you should do is you should practice. You should practice. Only after practice you will get to know how and what to do, where to do, and all. So Tinkercad is so simple. If you are starting with Tinkercad, you can see the errors where how you can try different kinds of boards like this here. So much of microcontrollers. You can practice any of them free of cost. You can replace this with different kinds of LEDs. And actually in this next section we are gonna deal more with this kind of boards in detail, like breadboards, different sets of LEDs and all. So stay tuned for the next video. Thank you.